Good day, Grade 12 learners. Welcome to today's Life Sciences lesson. My name is Vedika Maraj, and this lesson is brought to you by the Gauteng Department of Education in collaboration with Cybono Discovery Center. Today, we're going to be doing the second half of evolution, which is about evolution in present times and evidence of common ancestors for living hominids. I'm not alone today. I'm together with my colleague, Agnes, that will be sharing the session with me. So, firstly, as always, we like to start with our examination guidelines so you know exactly what it is that you need to study for. Just reminding you, the examination guideline gives you the scope of the topic. It tells you which paper the topic is in, and it gives you all the relevant information that you need to study in order to prepare for your examination or for your test or any formal assessment. So the first part we're going to be doing is evolution in present times. So if I can sum up this for you in a way, I would say that do you know how we spoke about natural selection, right? And we spoke about how natural selection is the survival of the fittest. And it was Charles Darwin who basically came up with this theory. And he also believed in gradualism. So he believed that in evolution, we have a series of small changes that occur over long periods of time. So eventually we have a change within the species, and they eventually change, right? But there are small changes. It's gradualism. Now, like I said, it happens over many thousands and thousands of years. However, it is also possible to see evolution in present time. So what we are saying is that in our lifetime, we can actually see evolution occurring. So you would ask me, now, ma'am, how would we see this? And this is because, let's look at the different options here, and then we can see. I'm going to go read through them. So firstly, you must know only one example, but I'm going to go through all of them so that you can get an understanding of what do we mean by this. So firstly, the use of insecticides and consequent resistance to insecticides in insects. Okay, so you know that they use insecticides to kill insects. But now, have you ever noticed that sometimes these insecticides stop working? Why is that? Have you ever heard of how something becomes resistant to drugs or resistant to insecticides? So that is what happens. We also get the development of resistant strains of tuberculosis causing bacteria to antibiotics due to mutations in bacteria, failure to complete antibiotic courses. Okay, so that's like when you have TB, you know, if you can maybe hear, or you probably have maybe somebody in the family or in the community where they had a very bad case of TB and then did not take the medication, did not take the antibiotics on time. So what happens is that this drug could not fight that virus, or I'm sorry, that bacterial infection. It could not fight it. It could also be because of a mutation. A mutation can happen in the population and that bacteria becomes resistant to drugs. Then we also have HIV resistance to antiretroviral medication. And then lastly, we have the bill and the beak and body size of the Galapagos finches. Okay, so that is something that we could actually see evolution in present times. So for this section, examiners love to ask investigative questions. So please make sure that you are going through enough question papers and you are able to answer investigative questions on this topic. Okay, because this is what they love to ask. And we're going to look at a few of them. So here's some of the examples that I was showing to you. I was discussing it, okay? The one I'm actually going to talk about here is this one. Okay, let's look at this diagram. So what they're saying over here is that we have a population of mainly susceptible bacteria, okay? And then, so those are the yellow ones. So those ones are susceptible bacteria. In other words, if you're going to administer antibiotics, they are going to be killed. But within this population, remember what Darwin says, we have variation. So within this population, there are two little red dots there, and those are our resistant bacteria, okay? So when they administer the antibiotics at this point, it's going to kill which ones? The orange ones, because they are the ones that are susceptible. But the two red ones are going to survive. And what does Darwin say? They are going to survive and they're going to reproduce and they're going to pass on the allele for that characteristic to the next generation. Yes, so now can you see we've got two, and we also had some other ones that didn't die. Okay, it doesn't always die. You know, every time you take an antibiotic, if you take one dose of antibiotic, is it going to kill your germs? No, not immediately, right? So what's going to happen is that over time, these orange ones are going to become less, but these red ones are going to become more. Okay, they're going to become more and more and more. So over a long period of time, you're eventually going to have a population of mainly resistant bacteria. Okay, so this is the example. There's also the example of coronavirus, of HIV. Then here we have the DDT, which is the insecticide I was telling you about, and then we also have malaria, the Anopheles mosquito that actually carries the malaria. Okay, oh, one more thing I wanted to say is that whenever we're looking at evolution in present times, so they're giving you an example of any of these, then you must remember natural selection. We're going to look at some examples of how they ask this question. Right, so this is taken from the Limpopo September 2022 paper. The question says the diagram below represents the changes in a population of bacteria as a result of exposure to an antibiotic over time. So what they're showing us over here is that we have diagram A and we have diagram B, and they're all different circles, right? Some are shaded, some are unshaded, and some have a diagonal print on it. Let's look at what the key is showing us. So they're showing us that this is the antibiotic resistance level, with the unshaded one being low and the shaded one being high. So the one in the middle will be moderate. Okay, so it's antibiotic resistance level. What does that mean? If something has a high antibiotic resistance level, then that means that they have a greater chance of being resistant. So they have a greater chance of the antibiotic not working with them, right? And if it has a low antibiotic resistance level, then that means that if the antibiotic is administered, then they will die. They are not resistant. So now they want us to explain in terms of natural selection the change in the proportion of the antibiotic bacteria in the population in diagram B. So firstly, I want to show you grade 12 is that they won't always tell you to explain in terms of natural selection. When you see this type of question, you are supposed to understand that we are talking about natural selection here. Okay, so in the beginning, as you can see there, what do we have? How many? Let's just count the spots before we carry on so that we can tell ourselves what actually happened in this population. So what I can see here is that we have 1, 2, 3, 4, 5. We have 5 that are having low antibiotic resistance level. We have 3 moderate, and we have 3 high. And then over time, we have a new population, which is diagram B, where we now have high levels. The high antibiotic resistance level are now more. They've increased, right? It's all of these. 1, 2, 3, 4, 5, 6, 7, 8. And we have 4 moderate. So all the ones with low antibiotic resistance level died. Why? Because they were not resistant to the bacteria, so to the antibiotic. So the antibiotic was administered and they died because they had low resistance. Right, so how would you explain this? What does Darwin first say? Darwin first talks about the large variation, but before that, we can even start with this point over here. Let's go to this 4th point. There is a large degree of variation in the bacteria population. Some are resistant to the antibiotic, others are not. And this is usually due to a mutation. So a mutation occurred which caused some bacteria to be resistant to the antibiotic, okay? So when the antibiotic was first used, the non-resistant bacteria died and the resistant bacteria survived to reproduce, therefore increasing the population of antibiotic resistant bacteria. There's also one point missing here that you can talk about passing down the allele. I want to just add that because this is an older question. We evolve as the question papers also evolve over time. We have to see how are they actually asking our questions going down the line. But the main thing is here is that, can you see that this looks very familiar to you? Yes, because it is natural selection. Let's look at another example. Another question. Explain why antibiotic resistance can become a severe health problem in hospitals. Yeah, you can just imagine. Why would this cause an issue? Because now we're in the hospital, they carry on administering this antibiotic and nothing is happening. Okay, so let's talk about that. We have overuse or frequent use of antibiotics may lead to the development of antibiotic resistant strains of bacteria or infections caused by these bacteria are no longer affected by the antibiotic treatment. Antibiotic resistance leads to higher medical costs, prolonged hospital stays, and increased mortality. So because it's an explain question, explain why, you cannot only say antibiotic resistance leads to higher medical costs and prolonged hospital stays. You need to say why. So it's very important that you are saying that they are overusing these, right? And they lead to antibiotic resistant strains. And that is what's going to cause more to be. So hospitals are going to have to administer more medication. The patients are not going to get better. So they're going to be staying in the hospital for longer. And this can also increase the mortality rate, okay? Because now people could die because the bacteria is resistant to the antibiotic. Right, let's look at another example. This is a scientific investigation, right, about malaria. Okay, so we're going to read through it slowly. You can also have a look at it and read through it. Oh, please remember that we also have a worksheet that has been emailed. And I think it's also available on the Pocket School website that you can use to actually see these questions. Right, the malaria parasite is transmitted to human blood by mosquitoes. People living in malaria-affected areas take anti-malarial drugs to prevent infection. If the anti-malarial drugs are effective, there should be no parasites in their blood. The presence of parasites even after treatment indicates that they have evolved to be drug resistant. Researchers wanted to determine if the use of anti-malarial drugs caused drug resistance in the malaria parasite. The following procedure was taken. Blood samples were collected from people in affected areas who were taking the drugs. The collection of blood samples was done in 7 villages in the affected areas. The blood samples were kept in the same laboratory and tested for the malaria parasite. The number of blood samples having the malaria parasite was counted. The investigation was repeated 3 times in the same 7 villages during a year. In total, 1,485 samples were collected and 551 had the malaria parasite. Now, this is giving us a lot of information. They explain to us about the malaria, and you are seeing that it's about natural selection and it's about evolution in present times. But then they have an important thing over here. This is the aim of the investigation. They wanted to determine if the use of anti-malarial drugs caused the drug resistance in the malaria parasite. That is the aim. How do we know? Whenever you see to determine, that is the aim. Okay? When we are talking about the sample size and how the sample was done, we are talking about a sample size over there. Okay? And they're giving us some other information. But let's first look at what they're going to be asking us, and then we can come back to this. So firstly, from the paragraph, you need to explain to us how is the malaria parasite transmitted to humans and how is it done? Because of what? Because of the mosquitoes. Yes, the mosquitoes are the ones that are transmitting it to the human blood. What is the independent and the dependent variables? Now, grade 12s, do you know how to identify these 2 variables? Firstly, the independent variable is the one that can be changed, okay? It is the one that the examiner changes or the investigator, the scientist is going to change. And the dependent variable is the one that changes because of the independent variable. So and where do we find these? In the aim, okay? So here we find it in the aim. Let's go back to the aim. Right, let's go back to the aim. They wanted to determine if the use of anti-malarial drugs caused drug resistance. So we have an anti-malarial drug, that's the one variable, and then we have drug resistance, that's the other variable. So which is the one that is going to be changing? It's going to be the drug resistance. So the use of the anti-malarial drugs is the independent variable, because now when they're doing the investigation, remember what they said, they're going to be giving it to them. They're going to be administering the drugs. So the use of the anti-malarial drug is going to be determined, how much they're going to be given is going to be determined by the investigation. But what they're going to see is the effect of this. That is the dependent variable, which in this case is the drug resistance. Okay, so what happens now when they administer the drugs? What happens to the drug resistance? Calculate the percentage drug resistance in the blood samples taken. Show all working and round off your answer to one decimal place. The percentage drug resistance in the blood samples taken. So they said there was 551, right? Of the 1,485, 551 were resistant. So if you have to work it out, you have to say 551 divided by 1,485, times it by 100, and you get 37,1 something. But because they told you to round it off to one decimal place, you had to say 37.1%. State two ways in which the researchers ensured the following: validity of the investigation. Now, when you see validity, you need to think to yourself, what was kept the same? Which variables were kept the same? So if you have to go back there, they asked you, how did the researchers ensure? How did they ensure? Ensured is in the past tense. Can you see that? So they're saying, what did they do? So when the question is asking you, what did they do? You must go back to the question. Go to the procedure, go to those bullets and see what did they do. Okay. So if you can remember, we can't go back now, but if you can remember, hopefully you have it in front of you. But these are the few things that were from the passage. Blood samples only collected from people taking the anti-malarial drug. Very important. They only took blood samples from those people. The same affected area of collection, the same villages, and the same laboratory. Okay, so those are the things that were kept the same. So you must just take it from what was given to you. When it comes to reliability, reliability is talking about how can you make the investigation more reliable. So here you need to be specific. Okay, but the three generic answers is that it's about sample size. So the larger the sample size, it increases the reliability. Repeating the investigation, okay, so maybe and repeating it, and also doing it over a long period of time. These are the things that we would say to have increased reliability. But you need to be specific. You cannot just say these three generic things because they told you what was done. Remember, how did they ensure reliability? They told you they repeated it 3 times. So that's repeat the investigation. They told you it was done in 7 villages. So that's quite a large sample size. It was done during a duration of over a year, so it was done over a long period of time, and the sample of 1,485 was collected, which is a large sample of people. Okay, so can you see that those generic answers I originally gave you, they fit into what was given here, but you won't get answers for that. You won't get marks for saying the generic answer. You need to be specific as it is here in this question, in this answer. Number 5. Describe how the malaria parasite developed drug resistance through natural selection. Yay! Once again, now you must know. When you have natural selection there, you must know, this is evolution in present times. I'm going to remember what Mrs. Maharaj said that day, right? So now remember they're talking about the malaria parasite. So you cannot now talk about TB. Okay, grade 12? You can't talk about HIV and coronavirus. You cannot make your own thing. They are telling you it's about the malaria parasite. So you need to talk about that. So what's the first thing you say? You first talk about variation. Yes, there was a variation in the population, in the malaria parasite population. You cannot just say there was variation in the population. You must be specific. In which population are you talking about? Okay, so it's in the malaria parasite population. Some parasites were resistant to the anti-malarial drugs and others were not. When parasites were exposed to the anti-malarial drugs, those that were not drug resistant did not survive and they died. Those that were resistant to the drug survived and they reproduced. And they passed the allele for drug resistance to their offspring. Very important sentence, this one. Don't forget it. Okay, don't leave it out when you're doing your natural selection. And this will result in the next generation having a higher proportion of parasites with drug resistance. Okay, So can you see that every single step of this is from the examination guideline? It's exactly natural selection the way you know it, but specific. So it's the examination guideline, but it's specific to this scenario. You speak about variation. You talk about what is the two differences in what is the variation. Then you talk about what happened. They were exposed to the anti-malarial drugs. The ones that were favored survived. The ones that weren't died. And what happens? They pass down the allele. The ones that reproduce, obviously, then they're passing down that allele to the next generation. And then eventually we're going to have a higher proportion of parasites. So what happens in the end, the result is the last point. Okay, so please you must be able to apply this natural selection to any given scenario. Right, that was a mouthful, right? Now we're going to move on to evidence of common ancestors for living hominids, including humans. Okay, so this is going to be divided by myself and Agnes. I'm going to do the interpretation of the phylogenetic tree to show the place of the family Hominidae in the animal kingdom. And Agnes will do the characteristics that humans share with African apes and the anatomical differences between African apes and humans. Okay. Right, so let's first look at our place in the animal kingdom. So when we're talking about this, we are talking about us as a species, human beings as a species. And what is our species called? Yes, we are Homo sapiens. And where do we fit in the animal kingdom? So we have our domain is called Eukarya. Our kingdom is called Animalia. Our phylum is called Chordata. Class Mammalia. Order is primates. Family Hominidae. And our genus is Homo, and the species is Homo sapien. Okay, so this is how we fit in. Everything is classified. Okay, we have a taxonomy for all living creatures, right? So we are all classified according to certain criteria. So this is our classification, and this is where we fit in. So if we have to look at this hominidae, I only want us to focus on this bigger, this lilac circle. Okay, if we look at hominidae, that's our subfamily name. And the hominidae was divided at a point. So do you know how people usually say that evolution is basically humans evolving from monkeys? Okay, that is not actually true. It's a very big misconception that people have. But you are life sciences learners, so you know the truth, right? And you know what's scientifically correct. And what happened is that so as you know, well, you have learned now at school, is that in evolution we have a common ancestor. Okay, so what they believe is that everything evolved from a common ancestor. So changes happened over time due to speciation, which you learned about already, right? So evolution and speciation occurs and different species evolve, but we all originate from a common ancestor. And as we go on, there are more further branches of speciation, and we have new common ancestors that are along the way. Okay, so at some point we were this family Hominidae, and then at some point that branch divided, okay, into two different species, which is the Homininae and the Gorillinae. So the Gorillinae is the one that went down to becoming the gorilla, but the Homininae is the one that divided into the Homo and the Pan. Okay, so the Pan is the one that's the chimpanzee, and the Homo is the one that evolved into being what we are today as Homo sapiens. Okay, so when we're looking at where we are and our place in the animal kingdom, I want you to just basically see from the slide that we did not evolve from monkeys, number one. Number two, we need us to see that our family name is Hominidae, and our scientific names are written as a genus and a species name. Our genus name is Homo. This one is gorilla. Pan, okay, the one that comes first, the first word in the species name is the genus, so that's the family name. And the second part is the species part, right? So it's Homo sapien, gorilla, Pan, troglodytes. And when you write it, please remember that you are going to you cannot write in italics. It is typed in italics, but you will underline it when you are writing it. You can also shorten it like this, but I would encourage you to not do that. only if it has been given to you in that form, in a diagram or a phylogenetic tree, then you can actually use it in that way. And then I want to explain to you that genus and genera. Okay, so those are the different ways that they can say the word. So don't be confused if they have to ask you what is the genus, right? It's a genus, or they can say genera. It's just that one is the plural form and one is the singular form. So this is just a lovely diagram to show us where our different groups are. So basically, if I can explain to you quickly in this way, here we have the common ancestor. And then we've got branches of speciation. So we branch into the Ardipithecus group. And then we had more speciation occurring into the Australopithecus group. Ardipithecus is a genus, Australopithecus is a genus name. We had further branching into the Paranthropus group, and eventually we have the Homo group at the top. And we are here, right at the top of the tree. Okay, so you can see how you see that because of the branches, you can see we did not evolve from the monkeys and the gorillas. Can you see that they branched off? We were all part of the same journey, but then due to speciation and environments changing and mutations and a whole lot of different things, and their speciation occurred and this branching occurred, so that we have all these different groups. Right. What is a phylogenetic tree? Firstly, not to be confused with pedigree diagrams, okay? A phylogenetic tree is a schematic representation that shows the evolutionary relationships within a set of organisms or a group of organisms. Whereas a pedigree diagram is a family tree. So a pedigree diagram is a family tree and it shows you inheritance of characteristics in a particular family. But a phylogenetic tree is showing evolutionary relationships. Okay, that is the difference. Philo means the organism's phylum group, that's what it refers to, and genetic means from the genes or relationship between the genes. And as I said, it should not be confused with pedigree diagrams. Okay, what do you need to know from a phylogenetic tree? Okay, I'm going to explain them to you in detail, but this is the things I want you to know. This pink speech bubble is very important. You need to know how to identify the common ancestor, who is extinct, when did the species on the diagram originate, how long did they live for, and when did they become extinct. These are the typical questions that are asked on a phylogenetic tree. So this is a quick showing you quickly how do we read a phylogenetic tree. So you have different ways. Okay, the phylogenetic tree, it can start with the common ancestor being at the bottom and it can radiate upwards like this diagram over here. You have a phylogenetic tree that can be read from left to right. You can have a phylogenetic tree that has rectangles on it to show you the different parts. It can have anything, literally anything. Okay, so it's very important that you are able to identify the important things on your phylogenetic tree. You don't know which one you're going to get. And you know what, K-12s, this is a skill. Answering questions on phylogenetic trees is a skill. You don't have to study for this. You don't have to know anything about human evolution in order to be able to do a phylogenetic tree. And you saw this actually first in grade 11 when you did plant diversity and animal diversity. That is where you did phylogenetic trees. Maybe you didn't know it at the time, but you did do it. Okay, so yeah, this one, number one, is the common ancestor. Number one is the common ancestor of species A, B, C, D, E, F, G, and H. So all of those in the present, one is the common ancestor of all of these. Okay, so this phylogenetic tree is read this way, where this is the past and this is the present. Always identify the past and the present, the first thing that you do. Then we had branching that occurred, speciation, and it went into this branch number 2. That's the next common ancestor. So we travel along a line until we get to a branching, another branching. When you get to another branching, that's when you know that this is now the new common ancestor. So number 2 is now the common ancestor for A, B, C, and D. But as this branch went on, we had another common ancestor here. So 3 is the common ancestor of B and C. Okay, so all of these are the common ancestor of, 1 is the common ancestor of all of these. 2 is the common ancestor of A, B, and C, not of this side. This side is different, this side. Then 3 is the common ancestor of B and C. Now let's look at the other branch. This one, come back to 1. This is another branch. So there's a branch here, there's a branch here, there's a branch here, and a branch here. So let's see this side. This point is the common ancestor of D, E, F, G, and H. This one is the common ancestor of E, F, G, H. This one is the common ancestor of E and F, and this one of G and H, the most recent common ancestor. Okay, so the question will tell you, if they have to ask you, what is the most recent common ancestor of G and H? You must know that it must be this one. You just follow the line down to where the last branching occurred. Okay, but what I want you to look at over here is that because of this branching, what we can understand is that these organisms are similar and these organisms are similar to each other. But they are not as similar. This group is not as similar as this group because we had a branching and there were more branchings occurring. And what we can also see from here is that B and C are more closely related to each other compared to A. Why? Because they had another branching occurring. 2 branched a longer time ago. A branched off a longer time ago compared to B and C. Are you with me? Okay, so this branching is called speciation. And what do you know about speciation? We have a development or the appearance of a new species. Right, this is a different phylogenetic tree now. It's being you read it from left to right. So here we also first we identify the timeline, million years ago. This is 5 and this is 0. 0 means present. So this is the present day, and then 5 is the past. Okay, so where does the common ancestor exist? In the past. Yes. So what is the common ancestor of all of these species? It is at this point over here. Okay, common ancestor. Then when the speciation and the branching occurs, all of these that came after the common ancestor are called the descendants. All those that came after the common ancestor are called the descendants. Okay, so here we have Australopithecus afarensis. And on this one, we had eventually this became the chimpanzee. So this is showing us the hominid, the simplified summary of hominids. Okay, so they're showing us that we were all together, but then chimpanzees branched off and they went on their own way. And we still have chimpanzees today. We cannot evolve from organisms that exist today. We couldn't have evolved from them, right? So far away that the chimpanzees branched off from us. We still have them today. Okay, so Australopithecus afarensis occurred, and then there was a branching into Homo habilis and Australopithecus robustus. Then we went to Homo erectus and Homo sapien. But what I want to show you here, I spoke to you what descendant means. Speciation is the branching. And then when the line stops in the middle of nowhere, that is meaning extinction. Okay, if the line travels to 0, that means that that organism is still present today. They're not extinct. But if it just died in the middle of it, it means that they are extinct. And the point of the branching, that point of this point here, for example, of the branching, that is when the organism originated. So if I wanted to calculate, for how many years did Australopithecus robustus exist on Earth? We would have to say, take this line, when it originated, we draw a line down to the bottom. That is 3 million years ago. That's when it originated. When did it become extinct? It became extinct at 1.5 million years ago. So we say 3 minus 1.5, and that equals to 1.5 million years. Not million years ago, because they're asking how long was it in existence for. It existed for 1.5 million years. Okay, but when did it become extinct? 1.5 million years ago. Are you with me? Okay, that's the difference. Now let's do some questions. The diagram below shows the evolutionary relationships between different hominids. Their average brain volume is also indicated. How many genera are shown in the diagram? Okay, so genera is the plural. Genera is the plural. So how many genera do we see here? Okay, so we have A africanus, so the A stands for what? Australopithecus. The H stands for Homo, and those are the only two that we see. So therefore, there are two genera. If they have to ask you what are they called, you would have to be able to say Australopithecus and Homo. When did A africanus become extinct? Now, you said, ma'am, you said if the line stops in the middle of the timeline, that means it's extinct. But now we have rectangles. Okay, I'm going to show you what the rectangles mean. The beginning, the start. Okay, firstly, what did I first say? Look at your timeline. 0 is present. 3.5 is past. Okay? So, the beginning of the rectangle is when they originated. The end is when they became extinct. Right. So, let's go to A africanus. Oh, it's the one that we were working with. And now we have to work out when did it become extinct. So, we go to the end of the rectangle in the timeline, and it is at 2 million years ago. It became extinct 2 million years ago. Right? That's the answer. Notice that we don't usually give marks for the unit, but when it comes to million years ago and million years, we want to test that. We need to know that you understand the difference. Therefore, the tick is afterwards, which means that you need to have 2 correct and million years ago correct in order to get 1 mark. Name 2 A africanus fossils found in South Africa. Grade 12s, you need to know all the fossils that were found in South Africa. So what are the 2 A africanus ones? There are actually 3, but you only needed to mention 2. Tahung Child, Mrs. Place, and Littlefoot. Well done. Those are the 3 you need to know. You need to know all of the South African ones. You need to know the scientist that was involved. And you know this from the last time's lesson, all the things that you need to know, right? Using only the species in the diagram, describe the fossil evidence that supports the out of Africa hypothesis. So they want us to only use these organisms that are mentioned here to describe the out of Africa hypothesis. Now, can you remember what the out of Africa hypothesis is? This is the one that shows us that all hominins originated in Africa. Okay, and all humans today originated in Africa. They originated in Africa and then they migrated out of Africa. And we have fossil evidence and we have genetic evidence to support this. Okay, so the fossil evidence basically is that the fossils of A africanus were found in Africa only. Okay, so A africanus was only found in Africa. Homo habilis was found in Africa only. So those are the more primitive ones. Did you see what came first? Africanus, then Homo habilis. These were found only in Africa. The old fossils of Homo erectus, here's Homo erectus. The old fossils were found in Africa. But the younger fossils of Homo erectus were found in other parts of the world. So that means that Homo erectus moved. Right, Homo erectus moved and it traveled out of Africa because they found fossils of it, older ones that were more older fossils were found there. And we don't mean as in old, as in they've been, lying around forever. We're talking about how many years ago they date them, right? The fossils. So how many years ago did it were they appearing in Africa or living in Africa? Okay, so that's what you say. They were found in Africa only. A africanus, H habilis found in Africa only. Her oldest fossils of Homo erectus were found in Africa only, whereas youngest were found in other parts of the world. Explain the influence of brain volume on the complexity of tools made by Homo habilis and Homo sapiens. Okay, so what does this mean? So as we know, Homo habilis is the first one to use tools. Okay, and what do we know about the brain volume? We know that the brain volume increased, okay, over time, right? So Homo sapiens have a bigger brain volume than Homo habilis. Therefore, the Homo sapiens were more intelligent than the Homo habilis, leading to the Homo sapiens developing more complex tools, and Homo sapiens made more, or you can say they made more specialized tools. Okay, so Homo habilis made more primitive tools, and the Homo sapien, because they had a greater brain volume, it meant greater intelligence. They were able to develop more complex tools. But what I need you to understand about this is that we have this progression, right? We have this progression of a species. So the ones that were there long ago were more primitive, and as the time went on and as they evolved, they became more intelligent, and they progressed. Okay, they became more intelligent, they had an increase in brain size, and everything that they did also became more complex. The tools that they used, everything that they did, all the interactions they had with people, everything changed over time. So what I need you to understand is that more further back we go, those were the more primitive species. And as we coming more to the present day, we have the more progressive species. Right, another phylogenetic tree quickly. Give the letter representing the common ancestor for all the species shown in the phylogenetic tree. So what did I say? If they wanted for all of the species today, you go right down to the bottom and it is at point V. That is the common ancestor for all of them. Identify the species that is most closely related to the old world monkeys. So you go to old world monkeys and then you see, okay, where closely related. So which one would be more closely related? So you go down to the branching and you see, okay, here we go. What is happening here? Okay, so we have this one over here. We had a branching over here. So it would be the gibbons. It is point U. Yes, you can say it's point U, and you can also say it's the gibbons because you see this branch. It was first V, then we went to U. That was the next branching, so it went this way and this way. So the most closely related one to the old monkey is the gibbon, or you can say U. Okay, because they didn't ask for common ancestor, they just asked for the species. Give a reason for your answer. So if you said gibbons, if your answer was gibbons, then you have to say they share the most recent common ancestor at U. If you had said U, then you needed to say the old world monkeys are directly descended from U. Okay? Then identify 3 species that share the common ancestor R. So let's go to R. Which are the 3 that share the common ancestor? So we just draw a line up. It's humans, it's chimpanzees, and gorillas. Humans, chimpanzees, and gorillas. Well done. Last question. State 3 characteristics of the upper limbs that humans share with group P. Okay, now this one is still coming, okay? Actually, Agnes is going to be doing this, but you've learned this in class already, so let's see how smart you are, okay? So what are the characteristics of the upper limbs that humans share with group P? So where's group P? Oh, these are the chimps, the gorillas, and the orangutans. So these are primates. Okay, this is the upper limb. This whole thing is an upper limb. I want to show you something. Agnes is going to do it also, but just to show you. The arms are upper limbs. Legs are lower limbs. Okay, this part from the elbow to the shoulder is the upper arm, and then the part from the elbow to the wrist is the forearm. Okay, very important that you understand these. So you can just think for yourself, what are these characteristics that we share with our primate cousins? We have freely rotating arms, we have long upper arms, we have rotation around the elbow joint, rotation around the wrist, bare fingertips, nails instead of claws. We have fingertips, opposable thumbs, and we have 5 digits per limb. Okay, I'm not going to go into them into much detail because Agnes is going to be discussing these with you, and she's going to explain to you all of them and ways to remember them. But so start thinking about that. We are now going to take a short break for about 5 minutes. So please don't go anywhere. Stay tuned, and we'll be back with the second half of our presentation. Thank you.
Good day, grade 12 learners, and welcome back to the second session. I just want to remind you that prelims are just around the corner. And just to say to you, prelims are like a dress rehearsal. You know, when you fit your dress and you want to check and see to look if you are okay, they are like dress rehearsal in preparation for the big show. So in this case, our big show is the end of the year exam. So as you are preparing, as you are rehearsing, make sure that you use those past papers. Answer the section A alone. Try to answer all those exam type questions in preparation for the big show, for the end of the year exam. Now with these words, I would like to bring you back to our session where we'll be looking at the differences and similarities between humans and apes. Now I want to pose these two questions to you to say, do you look like an ape? Do you look like other primates? We talk about the gorilla, the chimpanzee. Now you can answer this question at the end of this session. So there are those characteristics that makes us to differ with apes. There are those characteristics that makes us similar to the apes. When I talk about us, I'm referring to you, to myself as well. Now looking at this one, these are examples of chimpanzees and gorillas, right? So we're looking at those characteristics that might be similar with ours, and also the activities that they can do that we are also doing or performing. So look at this one. Other primates can handle objects, can handle the tools using their hands, as you can use yours as well. And then looking at some of the characteristics here, they have got 2 eyes, can you see? A pair of ears, the nose, the palates, upper and lower palates that we have as well. And look at this one. The older ones can even take care of the young ones. That's what we do as humans. You are 18 years today, you are 17 years today. Your mother took care of you when you were born up to this stage. Right. If you look at some of these chimpanzees and gorillas, or if you look at them, what makes us differ most that is visible now, they are covered with fur, whereas humans are covered with what? You are covered with skin, right? Looking at your mind the gap, study that diagram where it shows similarities between Homo sapiens and primates. Even in your question papers, you can get questions like this to say, give us similarities between Homo sapiens and other primates, or differences between Homo sapiens and other primates. Now, the first one that we'll be looking at is that Homo sapiens have large brain, large skull. Don't forget, the skull protects the brain. So with Homo sapiens, they've got large brain, large skull compared to their body mass. So we're looking at what? Similarities. We are the same in terms of the following characteristics that I'm mentioning now. Now, all eyes are in front. Talk about the Homo sapiens, the other primates, all eyes are in front, meaning you can see with your 2 eyes. Hence, we are saying we've got binocular vision or stereoscopic vision. So all eyes are in front. We've got freely rotating arms. So if you can rotate your arms, it means other primates also can do that. Vedika just mentioned that you need to make sure that you differentiate between the arms, between the legs, because what we are saying is the arms are the upper limbs, But when you talk about the legs, we're referring to them as lower limbs, right? So in case of the freely rotating arms, we've got these long bones. We've got this elbow. Those are joints. But then all sapiens primates, they've got freely rotating arms. And then also we've got long upper arms. This is the lower arm. This is the upper arm, right? We've got long upper arms like other primates. And then we've got these elbows that allows for rotation of what? Of the forearm. So meaning the forearm can rotate basically because of what? The elbow joints. I know you have already done all of this. So we are revising, we are rehearsing, we are preparing for our prelims. Remember, if you get it now, you are there. You are the winner, right? Also, Homo sapiens and primates do have what? 5 fingers. So in each arm, you've got what? 5 fingers, right? Now, with the 5 fingers, we have the opposable thumb. Don't just refer to it as a thumb. Say it's opposable thumb because it is opposing all the activities that are done by the other fingers. So we've got opposable thumb, which works in opposite direction to the fingers. We're still on the similarities between you and other primates, between you and the apes, between you and the gorilla, right? Keep it right there. Then next one, we've got flat nails. Look at your nails now. You can check your friend's nails now, but preferably look at yours. We've got flat nails, right? And then flat nails instead of claws, right? Or you've got bare fingertips. You can also check your fingertips, which has got what? Fingerprints. You've got bare fingertips with fingerprints. Think when you were taking your ID some other months back or a year back, they were using your fingertips to do what? To verify or to check your fingerprintings. The reason why they do that is because at a later stage, they can check or they would want to verify your fingerprintings if they are yours or what. Right? Now, look at this picture here. These are other primates. This is you. So the hands look similar because we've got what? Fingers. We've got what? Opposable thumb, which work in opposite direction to the other fingers. Okay? Now, all Homo sapiens and primates do have what? 2 mammary glands. 2 mammary glands, right? Remember, all glands secrete their secretions to the target organs. Obviously, with the 2 mammary glands that are in here, they secrete what? They secrete milk for the young ones. Okay. Then we've got eyes with cones and color visions. Remember when you did the eye, you did all the layers of the eye, the outermost layer, the middle layer, and the inner layer. On the retina, that's where you can see what? Eyes with cones for color vision. So you can differentiate colors now because of what? Your eyes have cones to help you for color vision. And then the other similarity, or the last one that we're going to share, is that we have got sexual dimorphism. Now with sexual dimorphism, one is able to differentiate between female and male of the same organism. So right now in class, I can differentiate that you are a girl, you are a boy. Same with animals, you can tell that this is a male, this is a female. So we've got sexual dimorphism there. And then let's look at the differences between humans and African apes. Remember, in the first slide, we were looking at the similarities between humans and other primates. Now we are looking at differences between humans and African ape. Right. So this is not a whole, but we call it what? Foramen magnum. Foramen magnum. So the differences there is, you talk about the position of the foramen magnum. So when you want to differentiate between the position of the foramen magnum between the two, between humans and African ape, let's look at number 4. This is our number 4. Now the foramen magnum is in a more forward position. Those 3 words are very, very important. You should indicate that the foramen magnum of the humans is in a more forward position so that you get a full mark. Why is it in a more forward position? So that the spinal cord can enter this foramen magnum vertical. So when it enters the foramen magnum vertical, when the spinal cord enters this foramen vertical, then it qualifies the organism to be bipedal. So with bipedalism, that indicates movement using what? 2 legs. Okay? But then if you compare the position of the foramen magnum of this 4 organism 4 or skull 4 with skull number 1. With skull number 1, the foramen magnum is in a more backward position. So it's important to indicate the direction, girls and boys. So the spinal cord in number 1, in the skull, in the African apes, it enters the foramen magnum horizontal. So it's in a more backward position so that the spinal cord enters horizontal. And that qualifies the organism to be what? To be quadruped. So with quadruped, it moves using what? The forelimbs and the hind limbs, right? Quad means 4, remember bi means 2. So more forward position in humans to allow the spinal cord to enter vertically, we refer to bipedalism. But when in one, for an example, in African apes, we say the spinal cord enters horizontal into the foramen magnum. It qualifies that to be quadruped, to walk on 4 legs. That is the 4 legs and the hind limbs. Those are the limbs. 4 limbs and the hind limbs. Right? Now we're looking at still on the differences in terms of the position of the foramen magnum. Can you see here? The spinal cord enters vertically so that it qualifies this to be bipedal, whereas with the African apes, the spinal cord enters horizontal so that it qualifies it, it makes it to walk on what? On the forelimbs and the hind limbs. Difference in shape of spine. So in terms of the spine, if you look at the humans, the spine is S-shaped, and then with apes, the spine is C-shaped. But then in terms of the pelvic girdle in humans, this is also important, girls and boys. With the pelvic girdle of humans, it's short and wide. What makes it to be short? Let's look at the diameter here. Now with this diameter between the two, this one has got a large or wide diameter, whereas this one is narrow. If you compare the two, they differ. Now what we're saying is, in terms of the pelvic girdle, the humans have short and wide pelvic girdle. It's short, it's even wide. And then with the gorilla, it's long. Can you see? It's long and narrow. So if you are asked to write the difference between the humans and the African ape in terms of the pelvic girdle, you need to indicate those two. Should you mention the short only or the wide only, you're going to lose marks. So in order for you to qualify for full marks, the humans have got short and wide pelvic girdle, whereas the gorilla here has got long and narrow pelvic girdle. Now the differences, looking at the pelvic girdle, remember the position of the foramen magnum makes humans to walk on 2 feet, is bipedal, and also these ones are quadrupt because the spinal cord enters horizontal. Now let's check, for argument's sake, we're looking at the bone structures or types of bones. Remember we did that in grade 10 when we were doing the skeleton. Look at the differences or the similarities. We both have got the long bone, the femur. Even this gorilla or other primates, they've got a long bone. We've got phalanges, they've got phalanges, right? But then what makes us different with these other primates in terms of the pelvic girdle? For the other primates, the pelvic girdle is long and narrow. This one is short and wide. Can you see that? You can compare the two there. That's how they differ, right? Let's look at the size of the brain. You can ask yourself in terms of the features like your head. Compare it with the bird, for an example, or any other animal, the dog. What's the difference between you and those animals? So when we compare the size of the brain between the humans and other primates, for an example, what we are saying is, if you look at the size there, the volume of the brain of the space there is 1.8 cubic centimeter. This one is 400. That's quite a huge difference. This means that the cranium, which is part of the skull, so this is the cranium, it is the skull, it is protecting the brain, or we can say the brain is found inside what? The skull. And then the bigger cranium indicates the bigger brain. Look at your head now. You've got a bigger brain as compared to those animals. So the bigger brain indicates, the bigger cranium indicates the bigger brain. Now the bigger brain tells that you are most intelligent compared to those other primates. So humans have a larger brain to body size, right? We are looking at the difference now in terms of the palate shape. Now with the palate shape, what I like with our subject, the life sciences, is that in most of the cases, we give you pictures and we will ask you on what you see. We don't give you abstract things in most of the times, right? So humans have curved, smaller jaw. Remember, these are the jaws. But then with chimpanzee, they are rectangular, bigger jaws. What else can you tell if you look at the differences there? Humans have more curved palate, whereas the chimpanzee, in this case, it has got a rectangular, bigger jaw. This is a chimpanzee, this is a gorilla, this is a Homo sapien, it's you. Now we are comparing the palate shape. We are saying it's curved, it's small, whereas with other primates, it looks like a rectangle. It's rectangular and it has got bigger jaws, Right, what else do you observe there? What do you see there? We've got the larger gaps in between the teeth. Whereas in Homo sapiens, we don't have those gaps unless if you decide to remove the teeth. But then with other primates, they've got bigger spaces in between the teeth. They've got larger canines, whereas with the Homo sapiens, they've got smaller canines. Right? Now, when it comes to dentition, each time when you talk about dentition, think of teeth. You should be knowing your dental formula by now. Now, with dentition, in terms of the gorilla, remember we've said it has got gaps in between the teeth. Now, those gaps, we call them the diastema. And then in case of men or humans, we've got small canines, whereas the gorilla has got large canines. We all have got molars. We all have got the premolars. In a way, up to this, you can tell whether they are your cousins or not. All right? You'll answer at the end when we are done. Now, other differences. Look at the gorilla, the face of the gorilla. It's sloping. It's sloping. Look at yourself. As humans, it's flat, flat, flat. So what we are saying is that the gorillas are prognathous, whereas are more prognathous and then non-prognathous in terms of the humans. Now let's check. This means that with prognathous, it means having a projecting lower jaw. It is projecting, as you can see. African apes have bigger jaws. They are bigger jaws. Humans have flat face than African apes. You've got flat face than African apes. But because of they've got bigger jaws, this makes their face to be having that slope, or they look protruding. So African apes' faces slope. They form a slope here. Humans have a chin. Can you see that? In terms of the cranial ridges, now look at the humans. You can touch your head. You don't have those cranial ridge, but with gorilla, with chimpanzee, can you see this is the ridges? These are cranial ridges, right? They like those bigger edges. But then with humans don't have cranial ridges. Those are the differences. Now with the brow ridges, remember these are eyebrows, right? Brow ridges. The humans, they've got reduced brow ridge. We do have that, but it is reduced as compared to the gorilla. It's big. So the gorilla, they do have brow ridge, whereas humans, they've got reduced brow ridge. Now let's quickly summarize the differences between humans and African apes. Remember, we did it one by one. You checked. I've shown you those pictures that will make you to recall, to remember, as you'll be responding to those type of questions. Now, if you are to tabulate differences between humans and African apes, remember you must compare same things on the right-hand side as well as on the left-hand side. So with humans, the foramen magnum is in a more forward position, whereas in the African apes, the foramen magnum is towards the back of the skull. And we are saying humans are bipedalism, they walk on two legs, whereas African apes are quadrupedalism. They walk on 4 limbs and hind limbs. And then in terms of the spine, you have seen the spine. With humans, it's S-shaped. With African apes, it's C-shaped. It's like a C shape. It's like an S shape. And then in terms of the pelvic girdle, we have seen that is shorter and wider in humans, whereas in African apes is longer and narrower. Let's talk about the cranium size. It's larger in humans, and that determines the intelligence, I've told you. And then with cranium size, is smaller in the African apes. The palate shape, we say it's semicircular. It's not a full circle, it's half. Semicircular, whereas the palate shape is rectangular in the African apes. Dentition, there are no gaps between teeth. In humans, you don't have gaps. And then we've got smaller canines, whereas with the dentition of the African apes, there are gaps between teeth. And that gap, we call it the diastema. And we've got smaller canines, humans, whereas African apes, they've got larger canines. And then with the face, remember, because of the large jaw of the apes, they are non-prognathous in terms of the humans, but then with African ape, they are prognathous. Relate the prognathous with what? The flat face, the sloping face. But then use our correct terms as you are answering those questions. Use the terms that we have been training you during the course of the year. So don't talk about the flat face, talk about the non-prognathous, whereas African apes, they are prognathous. What about the cranial ridge and brow ridge? They are absent in humans, and then cranial and brow ridges, they are present in African apes. Yes, we do have differences. Yes, we do have similarities between humans and African apes or other primates. So you need also, this is just a reminder to say the differences. You can use the study diagram of skull, pelvic girdle, etc. You can just have those actual ones at school as you are looking at the differences, the similarities, and compare. It will help you to remember as you will be responding to the questions. So these are type of questions that you can get, and in most papers, to those that have started with comparing a variety of question papers, these are examples of the types of questions that you might get. Right. So we're going to do few activities together. Please make sure that you practice with your friends. You practice alone. You practice in your group works. Remember, when I started, I said, this is the time to rehearse. This is a rehearsal time. Do a lot of practice. Now, a lot of practice is from a variety of question papers. So the diagram below represents the skulls, the pelvises of a human and a chimpanzee in no particular order. In no particular order. The diagrams are drawn to scale. That's what I like about, you don't have an excuse to fail life sciences, because we give you and we ask you questions on what is given. Like the first question says, tabulate 3 observable differences between skull A and skull B. These are the 2 skulls that we are comparing. And remember, it says 3 observable differences, meaning here we don't expect general responses, but you respond on what you see, on what you observe, right? Tabulate 3 observable reasons between the 2 skulls for 7 marks. So it means we've got 1 free mark there. 1 free mark for what? For a table. Don't give us a cross to say it's a table. So for your table, it must have borders. For your table, it must have correct headings. Are we together? Right. Now let's look at those differences between the two skulls. Remember, is 7 marks. 1 is for a table. It must be a good table. Then the 6 marks, obviously we're going to expect what? 3 differences, right? When you talk about the banana on the right, talk about the banana on the left. Don't talk about the banana this side, then on the side talk about the apple, right? So skull A, this is skull A, rectangular in shape or U-shape palate. Here is a rectangular shape. What about skull B? It's a rounded, it's like a C, it's rounded. It's like a C, shaped or semicircular or parabolic palate. Those are that are doing maths will know about a parabolic shape, right? Large canines for skull A. Can you see these are the canines we spoke about? But in this side, it's small canines. Now, I would advise you that when you start with the differences or given any question whereby you're looking at mark allocation, make sure that you start with those ones that you are certain, you are sure that these ones are correct. Because we are going to mark the first 3 here. And what will happen? If the first 3 are incorrect and the last 3 are correct, you're going to lose marks. So make sure that you are certain, you are sure that you start with the ones that you are sure of. The foramen magnum is in a more backward position. Can you see? It's in a more backward position. Whereas in this one is in a more forward position. Then skull A is prognathous. Remember, slopey. And then more protruding jaws. It has more protruding jaws. And then skull B, it is non-prognathous. It is less, or it has less protruding jaws, right? Correct weights. Use correct weights, use correct terms, use correct names, right? It's more pronounced zygomatic arcs, and then B, less pronounced zygomatic arcs. Think of these bones here. They are zygomatic arcs. I hope you see. Right. Gaps, diastema between the teeth. These are the gaps that we have indicated. And then this one, there are no gaps or there's no diastema between the teeth. That is skull B. So by mere looking before you can even respond to the question, looking at the features here, looking at all the characteristics, you can tell, you can identify whether this is human or this is other primates. All right. State why pelvis C belongs to humans. You look at the humans. Remember, we've spoken more on the differences, on the shapes between the pelvic girdles. So, state why pelvis C belongs to a human. Can you guess? No, don't guess. Give me the correct answer. Why is pelvis C? Why do we say pelvis C belongs to a human? Can you tell the difference now? I want to believe so. So it is short and wide. Look at the mark allocation. Remember, it's for 2 marks. We are not going to give you mark to say you have tried. At least you could say, you could tell it's short. We are not going to credit you marks to say at least you've got that wide, to say it's wide. So it's full marks or nothing. Hence we are saying you should indicate that it's short and wide, is long and narrow in other primates. So this is for a human because the pelvis is short and wide. You qualify for full marks there. Next activity, go on practicing, girls and boys. The diagram below shows the skulls of pelvises of different hominids. State the genus name of A. sediba and A. sediba like we did all the classification there with Vedica, is Australopithecus for 1 mark. Describe the shape of the spine of H. sapien. The spine, yes, we have spoken more around that one. We've said the spine is S-shaped. Remember, if it was A. sediba, it was going to be C-shaped. A sediba is thought to be a transitional species. What is a transitional species? State what is meant by a transitional species. Is an organism that has got what? Intermediate characteristics. Okay? Give the letter of the pelvis that would be representative of A. sediba. Right? So, give the letter there. It's A. Remember, with a transitional species, what did we say? It's an organism that has intermediate characteristics or common characteristics between the two species. If you've got two species, the one in the middle, it has got characteristics of both, hence we're referring to it as intermediate. So an intermediate or a transitional species is an organism that shows intermediate characteristics. Okay. Right? Next, the diagram shows the skulls and pelvises. 5. Explain why you chose A to be a transitional species. So, A, this one, remember we said is transitional species because it has got intermediate characteristics. Right? So, explain your answer. A has pelvis that is intermediate, is transitional. A is transitional between B and C. Right? Or you can say A has shorter and wider pelvis than B. Do you agree? Yes. That's what you can observe. A has shorter and wider pelvis than B. This is true. This is what we see, but not as short and wide as C. So if we compare the three, A is shorter and wider, or it has a shorter and wider pelvis than B, and then, but not as short and wide than C, right? Or you can say A, this one, has a longer and narrower pelvis than C, true, but not as long as narrow than B, okay? Next question, explain. Remember, with explain, you need the cause and effect when you answer or you respond to a question that needs explanation. Name and say name. I'm Agnes Marvel. But the minute you say, I'm Agnes Maharaj, that's not my surname. You're only going to get 1 mark for the name, but incorrect mark for the surname. All right, explain the significance of the change in prognathism from A. sediba, this is A. sediba, to H. sapiens. Explain that. A. sediba was prognathous. A. sediba was prognathous, as you can see the slope there, or more prognathous, while H. sapien, Homo sapien, are non-prognathous. So you basically are comparing the two. This is due to what? Smaller jaw. Remember, bigger jaw, larger jaw makes it to be prognathous. This is due to smaller jaw. With smaller teeth and also reduced chewy muscle caused by a changed diet to eating soft or cooked food. All right. Last question. Yes, we are going to give you a variety of questions. Now, this is a passage you need to read with understanding. Evidence from fossil of Homo erectus shows that they appeared in Africa about 2 million years ago. They spread to many parts of Asia. Homo erectus is the oldest known species to be fully bipedal and have a human-like body. Their brain size was smaller than that of humans. That we have proved that looking at the volume there of the brain size is bigger than of other primates. A prominent brow ridge was present over their eye sockets. Remember, you don't have. Describe how the fossil of Homo erectus are used to support out of Africa hypothesis. For 3 marks, yes, you describe the fossil Homo erectus. Remember, you respond based on the passage that is given. Now, this is the way you need to respond. The oldest fossil of Homo erectus was found in Africa, we are told in the passage. And while the younger fossils were found in other parts of the world or in Asia, it's in the passage. Kelson boy. Remember, we need you describing the fossils of Homo erectus as used to support out of Africa. So the oldest fossil of Homo erectus were found in Africa, while the younger fossil were found in other parts of the world, and that indicates that Homo erectus migrated out of Africa. Now, what is the difference between the two questions? This one, you are describing the fossil of Homo erectus as given in the passage, but this one, describe how other fossil. Remember, this one, we were referring to the Homo erectus given here, but in this case, describe how all other fossils. Remember, Homo erectus is not the only fossil, but we have got other fossils as depicted in our exam guideline. This one, you need to know your exam guideline to get the 4 marks. Listen, describe how all other fossil evidence is used to support out of Africa hypothesis. So you must say this according to exam guideline. So the other fossils, we are referring to what? Ardipithecus fossils were found in Africa only. Only is key. If you forget or if you write Africa, you're going to lose marks. So only here is key. Only here should be there. So Ardipithecus fossils were found in Africa only, nowhere else. Australopithecus fossils were found in Africa only. True. So both Ardipithecus and Australopithecus fossils were found in Africa only. This is as per exam guideline. Now, fossils of Homo habilis. These are other fossils. Fossils of Homo habilis were found in Africa only. Fossils of Homo habilis. So, Ardipithecus fossils, Australopithecus fossils, Homo habilis were found in Africa only. This is exam guideline. But then the oldest fossils of Homo sapiens were found in Africa. Did I say Africa only? No. So the oldest fossil of Homo sapiens were found in Africa. The younger fossils of Homo sapiens were found in other parts of the world. So make sure that you go back and study the exam guideline. Last question. Use the information in the passage regarding Homo erectus and tabulate 2 differences between the features of Homo erectus and Homo sapiens. Now it's simple there. You draw your table, correct headings, Homo erectus, correct headings, Homo sapiens. Homo erectus, they've got small brain, that we have proved. Homo sapiens, they've got larger brain. And then also prominent brow ridges, those are Homo erectus, whereas Homo sapiens, they've got reduced brow ridges. It is there, but it's small, it's reduced, right? Then What observation of the skull of Homo erectus would have led scientists to conclude that Homo erectus are bipedal? Remember, relate the bipedalism to what? To the position of the foramen magnum, right? What observation of the skull Homo erectus would have led scientists to conclude that Homo erectus was bipedal? The foramen magnum is in a more forward position. But if they spoke about the quadruped, you would be saying the foramen magnum is in a more backward position, right? Thank you so much. Go and rehearse. Don't forget, go and practice for the big show. And when is our big show? You practice for the prelims. Your big show is at the end of the year. You can make it. You are the winner. Thank you. Goodbye.